So this video was going to be about these new LED lamps from Poundland, and they initially started off with this, suddenly they brought out this range of fairly high powered ones, quite attractive looking lamps as well. And these are all rated about 5 or 6 watts, and I have to say they come pretty close to that rating when you actually test them. And then, before I'd even tested these, they brought out even more. They brought out a 3 watt globe, 5 watt globe, and then this little 5 watt GU10. So I started making a video, and then I just kind of aborted that video a little bit because it got very interesting when I started taking this one to bits. So let's concentrate on this one in the meantime. So this is a lamp that does actually draw about, let's see, what was it? It was the 4.6 watts. And it's very bright, and it's got just 10 LEDs. And the readings seemed strange. The current didn't seem to tally up with just 3 volt LEDs. And if I probe about, if I bring in the meter here, and I poke about in the live lamp, and I put it across, I've got it to 20 volts here, so I'm going to stick it across just one LED. Now, notice that the iPad has again introduced flicker. This is not really showing any significant flicker to me. It's showing it on the iPad with the refresh rate, but it's not showing it to me. So I'm going to dazzle myself here and try and poke in here, not get my fingers in here because it is live, and get across an LED. So let's see if I can actually get a connection here because it's so dazzling I can't actually see anything. So 17 volts across the LED. Now if I actually change this to the current setting, so I'm going to move the lead to the milliamps range, and I'll go up to the 200 milliamps. And then I'm going to short one of the LEDs out. This will skew the results slightly, but not that much, unless I touch something really important. Okay, so that's one LED shorted out, just showing about 28 milliamps. And I've had a close look. I've actually tried putting these, I'm going to change this lead back over to volts ohms. You'd never want to leave it in the current setting in case you pick out the leads up and just ram them into something because the current settings are dead short. I've mentioned that before, I'll mention it again because it's worth mentioning every time. So I've tried hot wiring one of these LEDs. I've jumped it over onto the power supply here with using the built-in, there's a couple of resistors in parallel in series with the LED circle because all the LEDs are in series. And I gently cranked the voltage up until it got to just above 12 volts or so, and then they just started glowing. And I was kind of expecting, if you consider that it's about, it was about 17 volts, and you divide that by roughly 3 volts per LED, it comes out there's going to be 5 or 6 chips in there. And I was expecting to see the chips, you know, dotted about inside, but all I can see is a rectangular section. When I bring it up dimly and use this magnifier, talking of the magnifier, just a slight distraction here, watch this. I don't know if you're going to see this or not. Yes, I think you are. That's one of the LEDs, the 100 watt LEDs I'm using in my 20 watt bench lights. And here's the other one, since I can just focus them directly onto the bench. And miracle of all miracles, the dead LED in it is now lit at the moment. Oh no, it just flickered there. There's a dodgy LED in there. It's nice that I can actually just project it onto the bench, so useful little magnifying glass. So getting back to this, the LEDs appear to be, if I get a notepad here, it's quite an odd, when you look at the top of the LED, the resin is sort of domed slightly in the middle, which does allude to what's happening here. If this is the LED, there's a sort of slight rim round the edge, it's got the resin, and then there's a slight raised impression where the chip obviously is, just showing a sort of blob in the middle, a rectangular, and that must just be, maybe, I'm not sure if it's 5 or 6 chips in series, and that's how they're making up the voltage here. So if you consider there's 10 LEDs, round about, what was that, about 17, 18 volts, so it's going to be at 180 volts, and you suddenly realise this. These LEDs are optimised for capacitive droppers because that makes it a very efficient way of using the capacitive dropper because you need a lower value capacitor. Talking of which, I've found that out yet. I don't think I've had that out yet because it's not coming out. Let's see if I can not destroy it in the process. Are the leads going to allow me to lift this out? Yes, they are. Big, big, thick leads. There's also a fuse or a resistor in line. What is that? So the capacitor is completely unreadable. Let's start snipping things out here. Here we go. What is a capacitor? 820 nanofarad, which is still quite a high value capacitor. What value is the little smoothing capacitor? 3.3 microfarad. Let's doodle the schematic out, because this is quite interesting, this one. It's a twist from the normal ones that use loads and loads of the individual LEDs. So it's going to be pretty much the classic. Now, what is this component that's down there? Is that just a resistor or something? Let's probe into it. It could be an inductor. I don't think it's an inductor. It might be an inductor. Oh, you know what? I'm going to cut that right out. Also, this housing appears to be metal inside. That's all very odd, probably to help with the thermal dissipation. Right, am I going to be able to hike this out without actually snipping the component in half itself? I'm not sure I am, but let's give it a go. Have I managed here? No, you know what? I'm just going to cut the lugs off the bottom and destroy this lamp completely. It's kind of semi-destroyed anyway, so there's no harm in finishing the job here. And that's the component I want here. What have we got? It's looking a bit like an inductor. How odd. Is this in some way trying to balance up with the capacitance, or is it for filtering? It might be for noise suppression, but it's a yellow, violet, red, so it's 4,700 microhenries, I'm guessing. I don't have a meter that just handy that actually measures inductance. That's something I should have. But anyway, do I have a meter that measures inductance? I don't think I've got an inductance meter. That's annoying. Oh, that's alright, that's something to get then, isn't it? So, let's doodle this schematic out. This reminds me, the other lamp I've seen that had the inductor in it was one of the Philips 2-watt lamps that also used a capacitive dropper and the multi-chip LEDs. Now I see text in this circuit board and it says YX-LED. Now is YX-LED not named a company? ZR-038-10C-A2. I'm guessing the 10C stands for the 10 of type C LED. 38. What was that current? Was that current about 38 milliamps? Oh, I can't actually remember now. I thought it was less than that. Yeah, so, right, the schematic. So let's just take 240 in. I'm not going to mark what's live, what's neutral, because it's bipin, it can go round either way. So it looks like we've got the usual arrangement that it's going into the capacitor, which is 820 nano, was that? 820 nano. 820 nano. 250 volt. Uh-oh. Would have been better if it had been 400. And there's a little surface mount resistor across that on the back, which is, going to need a magnifying glass for this, 105. It's 1 megohm, reasonable enough. Then that's going into a little MB10F rectifier. MB10F, which I shall lazily draw with just a diode. So that's AC in, AC in. The other terminal, the one from the choke, appears to be just going straight into the rectifier. Okay, so that's that side dealt with. Positive, negative. This is going to be fairly typical. The capacitor is going to be right across the output. Yep. So it's got the capacitor across the output. Now this was going up to 170 volts. What was the capacitance rating? It was 400 volt, 3.3 microfarad, 3.3 microfarad, 400 volt. Because it's quite a high voltage array of LEDs running at a lower current, it can be a lower value capacitor, but that's good that it's a 400 volt capacitor. The only bit's a bit dubious so far is the 250 volt rating of this capacitor. Oh, I'm talking shit actually. Do you know why? Because it's got the AC symbol after it, it's 250 volts AC, so it's probably rated the best part of 630 volt. I'm going to put the wee AC symbol after that and apologise profusely because that appears to be its AC rating. Good, that's good. With the little red capacitors, it's the DC rating, but this one actually looks like a... I was going to say it looks like an X2. It's got X2 printed on it, so let's also add that it's an X2 capacitor. Oh, let's also add 4,700 microhenries. He said, kind of messing up writing microhenries a wee bit. So the output is to the capacitor. We've got a discharge resistor across the capacitor, tacked right across the output of the bridge rectifier, in fact. Not quite across the pins, but just next to it, of 104. So that's a little 100k resistor. Then it's going from the... Just because of because of the layout of the PCB, they've got a couple of resistors that are wired in parallel, I'm pretty sure here, and they look like 100 ohm wired in parallel. I'm just going to check that and see if we get 50 ohm, roughly 50 ohm. Oh, actually, make sure I point the dial in the right direction, that'd be quite good. So it's these two tiny little resistors here. And we're going to get roughly 50 ohm, have I? Yes, I am. So that is two resistors, 200 ohm resistors in parallel on the negative. Two times 100 ohm. And then it's just going through the LEDs after that, and it's... I've got 5 LED chips or 6 LEDs. Let's just draw some LEDs because I'm not really sure. How do you draw a multi-chip LED? I'm not sure. There is a standard symbol for that, but yeah. So technically speaking, then I would say let's say 5 chips because it is a modest current, so the voltage would float up above 3 volts. I'm going to guess 5 chips in this. We had about, was it 17 or 18 volts? 17 divided by about, say, 3.3. Let's say 5 chips in each. So it's 50 LEDs, effectively, in 10 packs. Yes, so that is an interesting lamp. I think I may stock up on a few of those because I quite like them. I wonder... this one had similar test characteristics doing the electrical test on the outside. Look at the way that it's got plated through holes that are just everywhere in this to actually take the heat through in this one. This one is just the bare material, but it was kind of glued well in round the edge to probably couple it to a degree onto that aluminium housing. But yeah, this looks like the inside looks like it is aluminium. Let's do a wee continuity check on that, shall we? In case it's just a sort of coloured plastic. I don't think it is though. Yeah, it's all conductive inside. And it goes right down to the bottom, so I suppose that's ultimately going to make it a wee bit flame-proof as well. Yeah, that's interesting. Poundland LED lamps are really growing up very, very quickly. So yeah, that's just one of these lamps. Now we have to explore the others, but I think that's enough for the moment. That's been a very, very interesting lamp indeed. I might just get some more of those when I'm next in. Yeah, I was sure I had an inductance meter knocking about. Not the most accurate thing in the world. So I said 4,700 microhenries, and this thing is coming up 4.5 millihenries, so 4,500 microhenries. So yep, that definitely is a little inductor then. with an equivalent resistance of about 26.5 ohms. Well, I say equivalent resistance, I mean an actual resistance through the windings. Now, on the subject of these, while I'm here, so to speak, I popped the lid off one of the other lamps, and you know what? Does that look familiar? It's pretty much a clone of the circuit board, but with everything just really spaced out round the edge, so it's pretty much the same lamp. So that saves doing the full tear down this one because the same schematic applies, I think. So this is glued in. These lamps are nice because they've got ventilation slots in the back as well. And let's see how the spacing is, so let's whike this out. Because it saves doing a video per lamp, which should just get boring for some people. Lets us move on to other things afterwards if I can just get a few of these lamps out the way in this one video. The temptation is now to open the 3-watt one and see what the difference is, but yeah, we'll see how that goes. So yes, I'm going to get this out. I've already been quite destructive in opening this one. Oh, you know what, that's not going to come out too easy. I'll tell you what I'm seeing already. I'm going to put the power supply on here, and are these? No, I'm not going to put. I'm going to put the. Should I say not the power supply? The soldering iron. I'm going to put the soldering iron back off because these are the little press-in crimps. Am I going to pop these out without slashing myself? What I'm seeing inside this lamp is that the components are mounted actually quite proud of the circuit board, which is good. So there's one of the little studs. They're quite good actually. I like that. A very reusable base actually for other projects. I'm going to have to get a knife, a big pointy thing into this. Oh no, there it goes. So this is one of these the bases, the bayonet cap, the base that the wires are just poked through and then these studs are pressed in, and that not only acts as a contact but it locks the wires in. This should pop out nicely now. Yes, it does. Apart from that, a bit of glue. We do have, well, that's not the same size of inductor as the other one. Well, we have to slit that off now, don't we? Is that just a resistor or is it another inductor? I'm guessing the component values. This is rated the same. This looks like it might just be a resistor. Could be wrong. Let's do some tests. Let's just ram it into that wee tester again, in fact. That does that tests everything at once. Looks like a resistor, but it might be a small inductor, so I'll just shove that lead in there. And that one in there. These are universal little testers. There are much more better ones there, but these test everything. They just basically, it's a sort of open sourcey type component tester, and you get them from China and eBay. And they just, the modern ones actually identify components with little images of them. So it's testing. It says it's a 5 ohm resistor. Okay, it's not an inductor this time. Basically it's a fusible resistor. The capacitor, the electrolytic, is mounted way back from the case. Isn't that great? That is really nice they've done that, because that's going to keep it away from the heat of the circuit board. The circuit board in this instance, this one was relying probably on the heatsink compound around the edge and the sort of metallic interior there. This one doesn't have the metallic interior, but it does have the ventilation slots. And this one is a very large area of copper in the back here just to spread the heat about a bit. The component-wise is 101, 101, 104, 105, and if this is 3.3 megafarad, 400 volt, 820 nano, 250 volt AC, that is just the same, you know, I'll save the time. Here it is, here's the schematic for this lamp as well, with the only difference being that in this case it's a 5 ohm resistor, which I guess might actually be a 4.7 ohm resistor, because that's a nice, the closest standard value. If I could get the heat shrink off this without actually knocking all the markings off it as well, because the heat shrink is well onto it. Oh, I think I'm messing this up a wee bit. It's 4.7 ohm. So let's correct that again. 4.7. Okay, and that's really just acting in this instance as a basically it's a fuse. Okay, now that makes me wonder what's inside the 3-watt one. Okay, one moment while I just burst this open. One little bit of carnage later, let's update the drawing here, because the only difference is the same LEDs, the same voltage across them, but they're only running at 15 milliamps, much lower current, and all they've done is they've changed two components. This time it's still a 4.7 ohm resistor. They've changed the 820 nanofarad capacitor for 470 nanofarad, and they've changed the 3.3 microfarad for 2.2 microfarad. So all they've done is change the two capacitors in the back. The rest is all identical. And that kind of means that this lamp, the 3-watt lamp, is identically sized to the 5-watt lamp, but it means it's being run at almost half the power for the same component ratings. So that means the 3-watt one is potentially going to last a good length of time. Note again, the electrolytic has just been sat up a little bit to keep it away from the hot surface, although it's not going to get that hot. I like that one. It's nice to know that it's rated for 5 watts, but it's being run at 3. That's definitely, yeah, I'm going to have to get more of these as well. I've got too many LED lamps, but hey. Anyway, very, very interesting indeed. Very, very big step forward for the Poundland lamps. They're just surprisingly good. They're surprisingly interesting. I wonder how long the LEDs will last, and then wonder what this sort of longevity will be. But only one way to find out, and that's to use some of them. But yeah, good. That was fun.